Imagine you're on a treasure hunt, but your guide is a bird. That's the reality for honey hunters in parts of Africa. They rely on the greater honey guide to lead them to hidden bee nests. Pretty cool, huh?
Yeah, that's a pretty remarkable example of interspecies cooperation.
It is, and it's just one of the many fascinating things we're going to be talking about today in our deep dive into the world of honey guides and cuckoos.
Both are masters of brood parasitism.
And we'll be exploring excerpts from the book, The Bird Way by Jennifer Ackerman, to uncover their secrets. What do you say? Ready to dive in?
Absolutely. It's a topic that really pushes the boundaries of what we think we know about bird behavior and evolution.
Right, we're talking about bird siblicide,
Yeah.
egg mimicry, and even the possibility of a universal bird language for cuckoo.
It's a lot to unpack.
It is, but that's what we're here for. Let's start with this unique partnership between honey guides and humans. What makes this relationship so special?
Well, for starters, it's a rare example of interspecies cooperation, where both parties benefit. The honey guides, with their keen eyesight and sense of smell, can locate bee nests that humans would likely miss.
They're like little feathered scouts.
Yeah, exactly. And once they find a nest, they lead the honey hunters to it, using a series of chattering calls and strategic flights.
It's almost like they're intentionally communicating
Yeah,
with the humans, isn't it?
it really does seem that way. The honey hunters, they have specific calls and whistles they use to attract the honey guides, and the birds respond accordingly.
So it's not just the honey guides taking the lead, it's a two-way street.
Yes. Researchers have even found that playing recordings of these human calls can trigger the guiding behavior in honey guides, but other sounds don't have the same effect.
Wow. So it's not just a random coincidence then. It's a deliberate communication system that has evolved over time.
Exactly. And it's not limited to one specific culture or region either. Different groups of honey hunters across Africa have their own unique ways of communicating with honey guides.
And the birds seem to understand them all. Amazing.
It really is. It raises some intriguing questions about the evolution of communication and the potential for interspecies understanding.
It does make you wonder what else we might be missing. In terms of animal communication, we tend to think of humans as the only species capable of complex language. But examples like this suggest there's much more going on in the animal world than we realize.
Absolutely. And this honey guide human partnership isn't just a curiosity. It has implications for our understanding of animal intelligence, cultural transmission, and even conservation efforts.
You know, reading about the honey guides, I couldn't help but think, what's in it for them? They're doing all this work, leading humans to the honey. But they can't exactly crack open a beehive themselves, can they?
That's a great question. And that's where the beeswax comes in. You see, honey guides can't digest beeswax on their own.
Makes sense. It's pretty tough stuff.
Right. But when humans break open the hive to harvest the honey, they leave behind the beeswax, which is a high-energy food source for the birds.
So it's the reward for a job well done.
Exactly. It's a win-win situation. Humans get the honey they need, and the honey guides get access to a food source they wouldn't be able to get otherwise.
It's a classic example of symbiosis in action.
It is.
Okay, so we've got these helpful honey guides leading humans to hidden treasures. But, you know, every good story needs a twist. And in this case, the twist is that honey guides are also brood parasites.
Yes, there is a darker side to these seemingly helpful birds. As much as we might admire their collaborative spirit, we can't ignore the fact that they are also masters of deception.
Oh, this I gotta hear.
Brood parasitism is a fascinating, if somewhat unsettling, reproductive strategy that involves laying your eggs in other birds' nests and leaving the parenting duties to someone else.
I'm starting to see why you called it the darker side of the honey guide. It's not exactly what you'd expect from a bird that seems so cooperative with humans.
It's a bit of a paradox, isn't it? But from an evolutionary standpoint, it makes sense. Brood parasitism, while risky, offers a potential advantage in terms of reproductive success. By outsourcing the costs of raising their young, honey guides can potentially produce more offspring than if they had to care for them themselves.
So it's a gamble, but one with a potentially high payoff.
Exactly. And honey guides have developed some pretty impressive strategies to make this gamble pay off.
Okay, I'm hooked. Tell me more about how this brood parasitism actually plays out. Do they just drop their eggs in any nest they find?
They're much more targeted than that. One of their frequent targets is the little bee-eater, a small bird that nests in underground burrows. The female honey guide carefully chooses a bee-eater nest with eggs already laid, and then sneaks in and lays her own egg among them.
And the bee-eater parents don't notice. The extra egg, wouldn't they be able to tell it's not theirs?
You'd think so. But honey guides have evolved to make their eggs remarkably similar to those of their hosts.
Oh, so that's how they get away with it.
It's a form of mimicry that helps reduce the chances of the host rejecting the foreign egg.
So they're playing a game of deception from the very beginning.
Exactly. And it doesn't stop there. The real drama unfolds. Once the eggs hatch, honey guide chicks are equipped with a sharp, hooked beak, and they use this weapon to kill their foster siblings, ensuring they have all the parental care and resources to themselves.
Hold on. They actually kill the other chicks. That's brutal. It's starting to feel like we're watching a nature documentary.
Yeah.
With a very dark twist.
It is a bit unsettling, and the way they go about it is particularly chilling. Researchers have captured footage of honey guide chicks, still blind and featherless, instinctively feeling around the nest for their foster siblings and attacking them with their beaks. It's a behavior that's hardwired into them from birth.
You mentioned researchers capturing footage of this. That must be intense to watch. Do the bee-eater parents ever try to intervene?
Unfortunately, no. Bee-eaters nest in dark underground burrows, and their vision in low light is limited. They seem oblivious to the carnage happening right under their noses. There's even footage of bee-eater parents trying to feed the honey guide chick while it's in the midst of killing their own offspring.
That's almost too much to process. That poor bee-eater family. It seems like such a cruel strategy. How can this possibly be successful in the long run? Wouldn't bee-eaters eventually learn to avoid honey guides or recognize their eggs?
You've hit on a crucial point. The success of brood parasitism hinges on a constant evolutionary arms race between the parasite and the host. And that brings us to the fascinating world of cuckoos, who have taken this arms race to a whole new level. Cuckoos are the real celebrities of the brood parasite world. They've developed a whole arsenal of techniques to outwit their hosts.
Oh, yeah. Tell me more.
Well, some cuckoo chicks employ brute force, just like the honey guide chicks, using their sharp beaks or even their entire bodies to eliminate their nestmates.
It sounds like a scene straight out of a Hitchcock movie. But is violence their only tactic?
Oh, no, they're much more versatile than
Wow.
that. Deception is a big part of their game. For example, some cuckoos have mastered the art of vocal mimicry.
Vocal mimicry, so they can imitate other birds' calls.
Exactly. Take the Horsfield's hawk cuckoo, for example. These clever chicks can mimic the begging calls of an entire brood of chicks, even though there's only one of them.
Wait, so they're pretending to have siblings. Why would they do that?
It's all about maximizing food intake. By making the host parents believe they have a larger brood to feed, the cuckoo chick can trick them into bringing more food to the nest.
So sneaky, but does it actually work? Can the host parents really not tell the difference?
That's surprisingly effective. The cuckoo chick's mimicry is so convincing that the host parents often end up working themselves to the bone, trying to keep up with the demands of their super brood.
Talk about manipulative.
I know, right? There are documented cases of these cuckoo chicks growing to be much larger than their host parents, thanks to their deceptive tactics.
That's incredible, but
Yeah.
it can't be easy for the host birds to be constantly tricked like this. There must be some sort of defense mechanism.
Right. You're absolutely right. This constant back and forth between brood parasites and their hosts has led to an incredible evolutionary arms race. It's a battle of wits, with each side developing strategies and counter-strategies to outmaneuver the other.
So it's like a game of chess played out over millennia with the survival of each species at stake.
Exactly. And the first battleground, as you might imagine, is the egg itself. Hosts have evolved a remarkable ability to recognize and reject foreign eggs, often based on subtle differences in color or pattern, or even the texture of the eggshell.
So they become egg experts, able to spot even the slightest inconsistencies. But what about the cuckoos? How do they counter this defense?
Cuckoos, in turn, have evolved to become masters of egg mimicry. They can produce eggs that are almost identical to those of their hosts, making it incredibly difficult for the host birds to distinguish between their own eggs and the cuckoo eggs.
Wow, so they're not just dropping random eggs.
Yeah.
They're actually tailoring their eggs
Yeah.
to match those of their specific host species. That's incredible.
It is. And the level of mimicry can be astonishing in some cases. Cuckoo eggs are so close in appearance to the host eggs that even experienced ornithologists have difficulty telling them apart.
It really makes you wonder How they manage to pull that off? Is it a matter of genetics? Or do they learn how to mimic the eggs of their hosts?
It's a fascinating question, and the answer seems to be a bit of both. Cookies inherit a general predisposition to lay eggs of a certain type, but they also seem to fine-tune their egg mimicry based on the specific hosts they encounter. It's a testament to their adaptability and evolutionary ingenuity.
So it's like they have a basic blueprint for egg mimicry.
That they
can also improvise and adjust based on the situation.
Precisely. And this ability to adapt is crucial for their survival, especially in regions where they parasitize multiple host species.
I can imagine. Having to remember the different egg patterns of multiple hosts must require some serious brain power.
You're right, and it brings up another intriguing aspect of brood parasitism, the cognitive challenges it poses for both the parasite and the host.
Okay, I'm ready for another mind-blowing revelation. Tell me more about these cognitive challenges.
Well, for cuckoos, it's not just about laying eggs that look like those of their hosts. They also need to remember the locations of potential host nests, carefully time their egg laying to coincide with the host's laying cycle, and avoid detection by the host birds.
It sounds like a high-stakes game of hide and seek, with a whole lot of strategy involved.
It really is. And on the host's side, the challenge lies in recognizing and rejecting cuckoo eggs and chicks. This requires a keen eye for detail, the ability to learn and remember patterns, and a willingness to make difficult decisions, such as potentially sacrificing one's own offspring to avoid raising a cuckoo chick.
So it's not just a matter of instinct. There's a lot of learning and decision-making involved for both sides.
Exactly. And this cognitive arms race has driven the evolution of some truly remarkable adaptations, particularly in the realm of egg recognition and rejection.
Okay, you've got me intrigued. Tell me more about these adaptations. How do hosts get better at spotting cuckoo eggs?
One key adaptation is the development of individual-specific egg patterns. Some host species have evolved to lay eggs with unique markings, almost like fingerprints, that make it easier for them to distinguish their own eggs from those of cuckoos.
So they're like personalized egg signatures that make it harder for cuckoos to copy them perfectly. That's so clever.
It is, and it's not just about visual patterns. Some hosts have also evolved to incorporate ultraviolet markings, or eggs, which are invisible to the human eye, but can be detected by birds. This adds another layer of complexity to the egg recognition process.
I'm starting to see why. This is considered an evolutionary arms race. Each side is constantly upping the ante, developing new strategies and counter-strategies to stay ahead of the game. But if cuckoos are so good at mimicking eggs, why don't hosts just reject the chicks once they hatch? A cuckoo chick can't exactly disguise itself as a baby robin.
Right. That's a great question. And it brings us to another fascinating twist in this evolutionary saga, the phenomenon of chick rejection.
Chick rejection, you mean? Host birds actually kicking cuckoo chicks out of the nest. I thought they were stuck with them once they hatched due to imprinting.
You're right, imprinting, where parents form a strong bond with the first offspring they see, can make it difficult for hosts to reject cuckoo chicks. But once again, nature has found a way.
Of course it has.
Yeah.
Nature always seems to have a surprise up its sleeve. So how do hosts overcome this imprinting hurdle?
Believe it or not, the answer lies in Australia, the land of evolutionary oddities.
Australia. What's so special about Australian birds?
Well, for starters, Australian cuckoos are generally not as good at egg mimicry as their counterparts in other parts of the world. In fact, some of them don't even bother trying to blend in.
Really? They just lay their eggs and hope for the best. That seems like a risky strategy.
It is. But what's even more surprising is that Australian hosts, specifically fairy wrens, have evolved to recognize and reject cuckoo chicks rather than eggs.
Wait, so they've bypassed the whole imprinting problem. How is that even possible?
It's still not fully understood, but researchers believe that the poor egg mimicry of Australian cuckoos may have forced the hosts to find a different defense mechanism.
So it's a case of if you can't win at the egg stage, fight back at the chick stage. Fascinating.
It is. It really is. And you know, they've developed some incredibly clever strategies. One of the most fascinating is a system of vocal passwords. Fairy wren mothers teach their chicks unique vocal signals while they're still in the egg.
Hold on. They're teaching their chicks passwords before they've even hatched. That's wild. How does that even work?
The mothers repeatedly sing a specific call during incubation, and the embryos actually learn and memorize this call after hatching, The chicks incorporate this password into their begging calls.
So it's like a secret code that only family members know, and the cuckoo chicks haven't cracked the code yet.
Exactly. While cuckoo chicks are remarkably good at mimicking other bird calls, they haven't quite figured out how to learn. This embryonic password, it's a testament to the incredible adaptations that arise from this evolutionary arms race.
It's incredible. It's like a real-life spy thriller playing out in the bird world. But even with these vocal passwords, it seems like a risky move. For the fairy wrens to reject a chick, what if they make a mistake and reject their own offspring?
You're absolutely right. The cost of mistakenly rejecting your own chick is extremely high. So fairy wrens don't jump to conclusions. They gather evidence before making a decision.
So they're like tiny avian detectives, carefully considering all the clues before making a judgment.
Precisely. They take into account a number of factors before deciding whether or not to reject a chick. They consider things like whether there's a single chick in the nest, whether there are adult cuckoos lurking nearby, and even their own past experiences with brood parasitism.
It's amazing how much information they're processing and how much risk assessment is going on. But even with all these clever adaptations, brood parasitism must still have a significant impact on host bird populations.
Right. All right. It's put some pressure
on
host populations, but they have. Yet another line of defense, mobbing behavior.
Mobbing, like a bird gang.
Not exactly a game, but a collective defense strategy. When hosts spot a cuckoo near their nest, they often use specific alarm calls to rally other birds, both of their own species and even other species, to mob the intruder.
So they basically call for backup.
That's right. And this mobbing behavior can be quite effective. It can drive the cuckoo away, potentially even injure it, and alert other potential hosts to the danger.
It's like a neighborhood watch program for birds. But are cuckoos just sitting ducks in this situation? Surely they have some way to counter this mobbing behavior.
They do. Cuckoos are masters of disguise and manipulation. Some species have evolved to look like harmless birds of prey, essentially blending in with the crowd to avoid suspicion. Others have gone in the opposite direction, mimicking the appearance of predatory hawks.
So they either play the innocent card or use scare tactics. Cunning.
Exactly. And this mimicry can be incredibly effective. For example, the common hawk cuckoo looks so much like a sparrowhawk that other birds often mistake it for a predator and flee instead of mobbing it.
Talk about a wolf in sheep's clothing. It's incredible how cuckoos have evolved these complex strategies to manipulate not only their hosts, but the entire bird community. But you mentioned something earlier that I can't let go of, the possibility of a universal bird language for cuckoo. Don't leave me hanging. Tell me more about that.
Well, remember those mobbing calls that hosts use to alert others to the presence of a cuckoo? Researchers have started to notice that these alarm calls, while distinct for each species, share some striking similarities across different continents and even different bird families.
So birds from completely different parts of the world might be using similar calls to warn each other about cuckoos.
It's a tantalizing possibility. From an evolutionary perspective, it makes sense. A shared alarm call for a threat specific to nestlings, like a cuckoo, could be incredibly beneficial for multiple species. It's like having a universal warning system for a common enemy.
That would be incredible. Imagine a global network of birds communicating about the cuckoo threat. Is there any evidence to support this theory?
Researchers like Will Feeney in Australia have been collecting cuckoo alarm calls from all over the world to compare them while it's still early days in the research. The similarities he's found so far are certainly
intuitive. It's like a real-life avian mystery waiting to be solved. But if this universal cuckoo language does exist, how could it have possibly developed? Birds don't exactly have international conferences
for standardize their alarm calls.
Do they? It's thought that this type of convergent evolution happens because different species facing similar environmental pressures develop similar solutions. If a certain type of alarm call is particularly effective at repelling cuckoos, natural selection would favor birds that use that call, regardless of their location or species.
So it's not about conscious cooperation, but about independent evolution leading to similar outcomes.
Exactly. And it's not entirely unprecedented. Researchers have found similar patterns in human language, with certain words like star or knee appearing. In completely unrelated languages, it suggests that there might be some universal principles governing how we, and perhaps birds, develop language and communication systems. It's mind-blowing to think about the interconnectedness of all living things and how evolution can lead to such amazing and sometimes unsettling outcomes. But while we're marveling at the ingenuity of the host birds, it's easy to forget that cuckoos are facing their own set of challenges. Yeah, it's easy to get caught up in the host bird struggles, but what about the cuckoos? Their life can't be a walk in the park, can it?
You're right. Brood parasitism isn't a free ride for cuckoos. It's a demanding lifestyle, especially for the females who do most of the heavy lifting.
I bet.
Imagine having to scout out potential host nests, synchronize your egg laying with the host cycle, and avoid detection by the ever-vigilant hosts. It's a constant balancing act.
Sounds exhausting. And all of that effort just to sneak one egg into another bird's nest.
And even then, success is far from guaranteed. Only a small percentage of cuckoo eggs actually result in a fledgling. They face predation rejection by the host and competition with other chicks, whether cuckoo or the host's own.
Given those odds, why has brood parasitism persisted as a strategy? It seems like a lot of effort for such a small return.
That's the evolutionary puzzle, isn't it? But remember, it's all about maximizing reproductive potential over a lifetime. By outsourcing the cost of parenting, cuckoos can potentially lay more eggs and produce more offspring than if they had to raise their young themselves.
So it's a high-risk, high-reward strategy, I guess. But I imagine navigating that world of deception and trickery requires some serious brain power.
Absolutely. Cuckoos may not be known for their song learning abilities, but they excel in other cognitive areas, especially spatial memory and timing. They have to remember the locations of multiple potential host nests, track the stage of each nest, and precisely time their egg laying to match the host cycle.
It's like having a mental map of their territory with constantly updating information on nest availability and timing.
It's truly impressive. Studies have shown that female cuckoos, the ones responsible for finding and choosing nests, have a larger hippocampus, the brain region associated with spatial memory, than males. And they consistently outperform males in tasks involving spatial memory and navigation.
So the females are the real masterminds behind this whole brood parasitism operation.
I guess you could say that. But even with these impressive cognitive abilities, it still feels like the cuckoos are facing an uphill battle.
Well, yeah, they are. But it's important to remember, I think, that cuckoos aren't just heartless parasites. They're complex creatures, facing their own set of evolutionary pressures, just like any other species.
Right, it's easy to villainize them, but they're just playing the game of survival and reproduction, albeit with some unconventional rules.
Exactly. And their existence has led to this fascinating co-evolutionary dance with their hosts shaping not just their own behavior, but the evolution of entire bird communities.
It's a story of adaptation, deception, and resilience, one that highlights the incredible complexity and interconnectedness of the natural world. And who knows what other secrets these avian tricksters are hiding, just waiting to be uncovered.
Well, there you have it. Our deep dive into the world of brood parasitism has taken us from the cooperative honey guides of Africa to the cunning cuckoos of Australia. We've explored their remarkable adaptations, from egg mimicry to chick rejection, and even glimpsed the possibility of a universal bird language for cuckoo. I don't know about you, but I'm left with a whole new level of respect for the complexity and ingenuity of the bird world.
And a reminder that even in the seemingly ruthless world of nature, there's always more to discover, more layers of complexity, and more stories waiting to be told.
Absolutely. So next time you're out bird watching, keep an eye out for those honey guides and cuckoos. You might just witness a piece of this evolutionary drama unfolding right before your